This video is presented to you by Almighty Wisdom Incorporates. This video features the news of a new continent called the Greater Adria. Hope you enjoy. Geologists have discovered a new continent hidden in the Mediterranean region after analyzing all the mountain ranges from Spain to Iran in detail for 10 years. The research, published in the journal Gondwana Research, revealed how a piece of continental crust the size of Greenland that once separated from North Africa plunged into the Earth's mantle under southern Europe. Eighth continent on Earth, Greater Adria. Build the eighth continent on Earth. This piece of continental crust is called Greater Adria. Most mountain chains that we investigated originated from a single continent that separated from North Africa more than 200 million years ago, said principal researcher Du van Hinsbergen, professor at Utrecht University, Netherlands. The only remaining part of this continent is a strip that runs from Turin via the Adriatic Sea to the heel of the boot that forms Italy, van Hinsbergen said. Forget Atlantis. Without realizing it, vast numbers of tourists spend their holiday each year on the lost continent of Greater Adria, van Hinsbergen added. What took so long to discover Greater Adria? Most of this continent was situated underwater and formed shallow, tropical seas in which sediment deposited, for example in large coral reefs. The sedimentary rocks, in particular, were scraped off when the rest of the continent subducted into the mantle. Reconstruction of Greater Adria, Africa and Europe, about 140 million years ago. These scrapings are now the mountain belts of the Apennines, parts of the Alps, the Balkans, Greece and Turkey, the study said. The reconstruction was a collaboration between geologists from Utrecht, Oslo and Zurich. This is not only a large region, but it also hosts more than 30 countries. Each of these has its own geological survey, own maps, and own ideas about the evolutionary history, van Hinsbergen said while explaining why it took researchers so long for the discovery. With their reconstruction of the lost Greater Adria, the geologists have made a substantial contribution to fundamental knowledge about mountain range formation. For the reconstruction of this region, the geologists made use of the advanced plate tectonic reconstruction software plates. Mediterranean region, most complex region on Earth. The Mediterranean region is geologically among the most complex regions on Earth. Plate tectonics, the theory that explains the formation of continents and oceans, assumes that the various plates of the Earth do not internally deform when they move with respect to each other along large fault zones. However, in the Mediterranean region, and especially Turkey, that is not the case. The Mediterranean region is quite simply a geological mess, van Hinsbergen said. Everything is curved, broken, and stacked. Compared to this, the Himalayas, for example, represent a rather simple system. There you can follow several large fault lines across a distance of more than 2,000 kilometers. Forget the legendary lost continent of Atlantis. Geologists have reconstructed, time slice by time slice, a nearly quarter-of-a-billion-year-long history of a vanished landmass that now lies submerged, not beneath an ocean somewhere, but largely below southern Europe. The researchers' analysis represents huge amount of work, says Laurent Jolivet, a geologist at Sorbonne University in Paris who was not involved in the new study. Although the tectonic history of the landmass has been generally known for a few decades, he says, the amount of detail in the team's systematic time-lapse reconstruction is unprecedented. The only visible remnants of the continent known as Greater Adria ray limestones and other rocks found in the mountain ranges of southern Europe. Scientists believe these rocks started out as marine sediments and were later scraped off the landmass surface and lifted up through the collision of tectonic plates. Yet the size, shape, and history of the original landmass, much of which lay beneath shallow tropical seas for millions of years, have been tough to reconstruct. For starters, Greater Adria had a violent, complicated history, notes Du van Hinsbergen, a geologist at Utrecht University in the Netherlands. It became a separate entity when it broke away from the southern supercontinent of Gondwana, which comprised what is today Africa, South America, Australia, Antarctica, the Indian subcontinent, and the Arabian Peninsula about 240 million years ago, and started to move northward, scientists believe. About 140 million years ago, it was a Greenland-sized landmass, largely submerged in a tropical sea, where sediments collected and slowly turned into rock. Then, as it collided with what is now Europe between 100 million and 120 million years ago, it shattered into pieces and was shoved beneath the continent. Only a fraction of Greater Adria rocks, scraped off in the collision, remained on Earth's surface for geologists to discover. Another complication is that Greater Adria rocks are dispersed across more than 30 countries, in a swath from Spain to Iran. So, like the rocks themselves, data have been scattered and thus are difficult to collect, Van Hinsbergen says. And finally, he notes, until the past decade or so geologists haven't had the sophisticated software needed to perform such Byzantine reconstructions. The Mediterranean region is quite simply a geological mess, he says. Everything is curved, broken, and stacked. In the new study, Van Hinsbergen and his colleagues spent more than 10 years collecting information about the ages of rock samples thought to be from Greater Adria, as well as the direction of any magnetic fields trapped in them. That let the researchers identify not just when, but where, the rocks were formed. Rather than simply moving north with no change in its orientation, Greater Adria spun counterclockwise as it jostled and scraped past other tectonic plates, Van Hinsbergen team reports this week in Gondwana Research. Although the tectonic collision happened at speeds of no more than 3 to 4 centimeters per year, the inexorable smash-up shattered the 100-kilometer-thick bit of crust and sent most of it deep within Earth's mantle, Van Hinsbergen says. The study is not the only evidence for Greater Adria as a lost continent. Other researchers who use seismic waves to generate computerized tomography-like images of structures deep within Earth have created in Glass of the underworld a graveyard of slabs of crust that have sunk into the mantle. This research shows that portions of Greater Adria now lie as much as 1,500 kilometers below our planet's surface. The map of the world looked very different 240 million years ago. Earth's modern-day continents were joined together in one Pac-Man-shaped supercontinent known as Pangaea, which eventually split into two fragments, Laurasia in the north and Gondwana in the south. The former became Europe, Asia, and North America. The latter dispersed to form modern-day Africa, Antarctica, South America, and Australia. But now, scientists have discovered the fate of a fifth continent that was born from Gondwana's bosom, which they named Greater Adria. A study published last week showed that geologic forces slowly shoved the Greenland-sized landmass underneath southern Europe between 120 million and 100 million years ago. The continent was already half submerged to start, but as it rumbled toward the Earth's mantle, the rocky inner layer of our planet, its top layer got peeled away, jutting up to become fodder for mountains in what are now 30 European countries. Van Hinsbergen, the lead author of the study, compared Greater Adria's subduction to the act of shoving a clothed arm below a table's edge. Suppose you have a sweater on, he told Business Insider. As you push your arm under the table, the sweater sleeve stays behind, getting folded and jutting upward. The folded sleeve is the equivalent of the upper few kilometers of Adria's crust, and your arm is the plate that is now sinking in the mantle, hundreds or even thousands of kilometers below our feet, Van Hinsbergen said. Those sweater folds became Eurasian mountain belts like the Apennines in Italy, the Dinarides in Bosnia and Herzegovina, the Swiss Alps, the Zagros Mountains of Iran, and the Himalayas. Reconstructing Greater Adria's geologic history in order to piece together Greater Adria's past, Van Hinsbergen and his colleagues spent a decade aggregating geological data from countries across Europe, North Africa, and Western Asia. Naturally occurring magnets in the Earth's crust can help scientists track 240 million-year-old tectonic plate movements. When hot lava cools at the boundary between two shifting plates, it traps rocks containing magnetic minerals that align with the Earth's magnetic fields at the time. The rocks keep that alignment, so scientists can use their orientation to calculate where those magnets were on the planet. Millions of years the researchers looked at magnetic rocks from 2,300 ancient sites across the Mediterranean region. Then they used that data to create computer simulations of the movements of Earth's tectonic plates before, during, and after Greater Adria's descent into the mantle. the researchers determined that the hidden continent broke off of what is now Africa 220 million years ago, then further splintered away from what became the Iberian Peninsula 40 million years later. By about 140 million years ago, Van Hinsbergen told Live Science, Greater Adria was likely a string of archipelagos. At that time, Adria probably looked like modern-day Zealandia, the mini-continent that underpins New Zealand's North and South Islands. Only 7% of Zealandia is above sea level. Then, between 120 million and 100 million years ago, the jostling of Earth's tectonic plates forced Greater Adria down into the mantle, under what is now southern Europe. The deepest portions are now at a 1,500 km 932 mile depth below Greece, Van Hinsbergen said. The study authors also discovered that some splinters of Greater Adria didn't subduct under Europe and instead remained above sea level. They eventually became parts of Italy, like Turin and Venice, and the Istria region of Croatia. Knowing what the Earth looked like millions of years ago might aid the search for valuable mineral deposits. According to Van Hinsbergen, reconstructions of our planet's geologic history can help countries and companies looking to mine valuable mineral deposits because scientists can highlight regional patterns in the way certain magnetic materials are deposited in the Earth's crust. Metals, ceramics, building materials, everything came out of a rock, he said. You don't find the next gold or copper mine, or the 25 materials you've never even heard of that make your iPhone work, by taking a stroll in the woods. Geologic reconstructions could also help researchers better understand how existing mineral and ore deposits, ones we already know about, formed and where any remaining materials might be buried.